wabarakatuh.
Okey, pertama sekali saya ingin ucapkan selamat datang ke sesi Collaborative Teaching Siri 1. Okay, saya Puanku Azlina, Akil daripada UiTM Perlis. Okay, those yang belum isi attendance, okay, sila isi attendance dalam UFuture mengikut kelas masing-masing. Okay, dan yang kedua, sila mute mikrofon anda. Okay, unless you ada soalan yang nak bertanya kepada saya lah ya. Okay, saya ulang sekali lagi, sila mute your microphone unless you have any questions. Okay, saya ulang sekali lagi. Those yang baru masuk, sila isi attendance di dalam UFuture mengikut kelas masing-masing. Okay, untuk sesi collaborative teaching ni, okay, saya akan menggunakan example daripada buku inilah ya. Ini adalah manual yang saya guna dalam kelas saya. Okay, dan juga Puan Jasmani, saya rasa dalam UiTM Tapa pun mungkin ada yang mengguna buku tersebut. Atau kalau yang tidak menggunakan buku tersebut, you all boleh standby pensel, pen dan kertas lah ya. Okay, kita mula sekarang . Okay, solving linear differential equations using variation of parameters. Okay, what is a variation of parameters? Okay, variation of a parameter or variation of parameters is a method to find the particular solution, YP, of any non-homogeneous differential equation. Okay, you have learned how to solve homogeneous differential equation and how to solve non-homogeneous differential equation using undetermined coefficient. Okay, so here we will learn how to solve non-homogeneous differential equation using variation of parameter. Okay, for non-homogeneous second order differential equation, okay, we have learned how to solve constant coefficient and variable coefficients. Okay, for variable coefficients, we have Cauchy-Euler equation and non-Cauchy-Euler equation. Okay, up to this moment, I hope all of you recognize or have identified what is called second order non-homogeneous constant coefficient and second order non-homogeneous variable coefficient. For the non-homogeneous second order differential equation, the general solution is given by y equal yc plus yp. Yc is a complementary solution. Yp is a particular solution. Okay, next, look at the procedures to solve the non-homogeneous second-order differential equation using the method of variation of parameters. Okay, step number 1, we find YC. Okay, so YC is C1 times Y1 plus C2 times Y2. C1 and C2 are arbitrary constants. Okay, for constant coefficient, okay, on the left, the general solution is given in the table. Okay, so you just put YC. Okay, for real and different roots, okay, YC equals C1 exponent M1x plus C2 exponent M2x. Okay, and on the right hand side, this is solution to the homogeneous Cauchy-Euler. Okay, so for YC, you just put YC equals C1 x to the power M1 plus C2 x to the power M2. Okay, for the second general solution, this is when the roots are real and equal. Okay, so on the left hand side, this is the complementary solution for constant coefficient, and the right hand side, this is the complementary solution to the homogeneous Cauchy-Euler. Okay, the third one, this is the general solution when the roots are complex number. Okay, so this is on the left hand side, this is the general solution or the complementary solution for the constant coefficient. And on the right hand side, this is the complementary solution for the Cauchy-Euler. Okay, once we found YC, the next step is we find YP. Okay, here YP is by using variation of parameter. Okay, first and foremost, the coefficient of Y double prime must be positive 1 if the highest derivative is second order. Okay, so again, you must make sure that the coefficient of second derivative must be positive 1. Okay, so for the constant coefficient on the left hand side, okay, after you divide by A, okay, you get Y double prime plus B over A times Y prime plus C over A times Y equals F of X over A. Okay, and then for the Cauchy-Euler, you must divide by AX squared. Okay, so you get Y double prime plus BX over AX squared times Y prime plus C over AX squared times Y equals F of X over AX squared. If you can see, I highlight F of X over A, F of X over AX squared. Okay, this means the term on the right hand side of each equation are very important. Okay, so if you did not divide by A or AX squared, so it will affect the whole solution, and then the solution is wrong. Okay, next we set out YP. First, we must write the general form of YP. Okay, we can write YP equals U1 Y1 plus U2 Y2. Okay, Y1 and Y2 are from complementary solution. Okay, next, we set up system of equations to find U1 prime and U2 prime. Okay, for constant coefficient, okay, the system of equation is Y1 U1 prime plus Y2 times U2 prime equals 0. And the second line is Y1 prime U1 prime plus y2 prime times u2 prime equals f of x over a. As you have learned in linear algebra, the system of equations can be transformed into a matrix form. Okay, so you can write, okay, this is 4 by 4 matrix. Okay, the first row we have y1, y2, and the second row we have y1 prime, y2 prime. And for the second matrix, this is matrix 2 by 1. Okay, we write u1 prime, u2 prime, and on the right hand side, there is another 2 by 1 matrix, 0 and f of x over a. Okay. Similarly, for Cauchy-Euler, okay, the system of equations can be transformed into matrix. Okay. And then we will find u1 prime, u2 prime using Cramer's rule. Okay, first we find Wronskian or W. Okay, Wronskian, how to find Wronskian? You just take from the 2 by 2 matrix. Okay, here Wronskian is a determinant of matrix, not a matrix. Okay, this is a determinant of matrix. And then we find W1. W1, we replace the first column in Wronskian, okay, by the term on the right hand side of equation. Okay, and then we maintain the second column. So here W1, we write 0, f of x over a, or f of x over ax squared. Okay, if the equation is Cauchy-Euler, and then we maintain the second column. Okay, next we find W2. Okay, W2, we maintain the first column, and then we replace the second column with term on the right hand side. Okay, so we have W, W1, and W2. Okay, all are determinant of matrix. Okay, next we find U1 prime. Okay, the formula is W1 divided by W. Okay, so here we can calculate. Okay, W1 times W. W1 divided by W. Okay, so we just multiply diagonally. Okay, so this is number 1. Okay, so 0. And then minus y2 times f of x. Then for u2 prime, the formula is w2 divided by w. Okay. So you just multiply diagonally. Okay. Okay, next. Since we have u1 prime, u2 prime, we can find u1 and u2 by integrate both of them. Okay, so u1, you integrate u1 prime, and then u2, you integrate u2 prime. Okay, once you have found u1 and u2, okay, just substitute in the general form of yp and simplify the terms if necessary. Okay, next, the general solution is given by yc plus yp. Okay, finally, if we have initial conditions, then we can apply initial condition. Okay, next, look at example 1. Okay, I would like to remind you, okay, if you have any questions, okay, please unmute your microphone. Okay, you can ask me during my presentation. Okay, you can interrupt me during my presentation. Okay, solve the following non-homogeneous differential equation using variation of parameter. Okay, the differential equation is y double prime minus 2y prime plus y equal 0. Equals exponent x ln x. Okay, y double prime minus 2y prime plus y equals exponent x times ln x. Okay, this is from example 4.16 in the manual or in the book. Okay, since this is non-homogeneous differential equation, the first step, we must find YC, the complementary solution. Okay, the complementary solution is the solution to the homogeneous differential equation. So in this case, the homogeneous differential equation is y double prime minus 2y prime plus y equals 0. Okay, so we find the characteristic equation. Okay, the characteristic equation is m squared minus 2m plus 1 equals 0. Okay, so this is quadratic. Okay, we can factorize or you can use quadratic formula. The roots are 1 and 1. Okay, so the roots are repeated roots or real and equal. Okay, so the complementary solution is C1 times exponent x plus C2 times x times exponent x. Okay, next. Okay, we set up YP. Okay, from YC, okay, C1 exponent x plus C2x times exponent x. Okay, Y1 is exponent x and Y2 is x exponent x. Okay. Okay, then we set up system of equation. Okay, before that, we need to find y1 prime and then y2 prime. Okay, y1 prime, you differentiate exponent x, you get exponent x. Okay, for y2 prime, since y2 is a product of two functions, polynomial and exponential function, so we use product rule. Okay, so we get x exponent x plus exponent x. Okay, so this is y2 prime. Okay, next, we set up system of equation. Okay, or you can write in matrix form. Exponent x, x exponent x, and then the second row, exponent x. Okay, x exponent x or exponent x plus x exponent x, and then we have u1 prime, u2 prime, times okay, equals 0 exponent x ln x. Okay, make sure that the coefficient of y double prime is positive 1. So here, okay, since the original differential equation is y double prime minus 2y prime plus y, so we do not have to divide by any numbers. Okay. So term on the right hand side is still exponent x ln x. Okay, next we find Wronskian. Okay, just take the 2 by 2 matrix here. Okay, and find the determinant of the matrix. Okay, So here you multiply exponent x times exponent x plus x times exponent x, and then you minus exponent x times x exponent x. Okay, so here you get e to x exponent to x plus x exponent to x. This one minus x exponent to x. Okay, so you get exponent to x. Okay, for W1, okay, you replace the first column with term on the right hand side of the matrix. Okay, that is 0 exponent x ln x. Okay, you maintain the second column of the matrix. Okay, so here we have 0 times exponent x plus x exponent x, we get 0. Okay, minus x exponent x times exponent x ln x. So you get negative x exponent to x ln x. And then for W2, we maintain the first column. Okay, we replace the second column with the term on the right hand side of the matrix. Okay, so now we multiply exponent x times exponent x ln x minus 0 times exponent x, which is 0. Okay, so we get exponent 2x times ln x. Okay, next, u1 prime, okay, w1 divided by w. Okay, w1, what we got just now, okay, divide by exponent to x, the Wronskian. Okay, so there are terms can be cancelled. So we have negative x ln x. And then for u2 prime, w2 divided by w. Okay, so exponent 2x ln x divided by exponent 2x. Okay, this term can be cancelled. So you get ln x. Okay, next, we find u1 and u2. Okay, u1, we integrate negative x ln x with respect to x. Okay, so here we use integration by parts. Okay, so here u is ln x, dv is negative x dx. So du, differentiate ln x, you get 1 over x dx. And then integrate dv, okay, you get negative x squared over 2. And then substitute into the formula, uv minus integration of v du. Okay, u is ln x, v is negative x squared over 2 minus integration of negative x squared over 2, du is 1 over x dx. Okay, so we rewrite. Okay, so here we can write negative 1 over 2x squared times ln x. Okay, here we get negative and negative positive. X squared over 2 times 1 over x, we get half times x. Okay, so now we integrate x, we get x squared over 2. Okay, so u1 becomes negative 1 over 2 times x squared ln x plus half times x squared. Okay, next, we find u2, we integrate ln x. Okay, here we also use integration by parts. U is ln x, dv is dx. Okay, so you differentiate u or you differentiate ln x, you get 1 over x. And then to get v, we integrate dv, we integrate dx, we get x. Okay, so substitute into the formula. So we have ln x times x minus integration of x times 1 over x dx. Okay, so x and 1 over x can be cancelled. So we integrate 1, we get x. Okay, so u2 is x ln x minus x. Okay, so for the particular solution, okay, we have this one is y1, u1, This is y2 u2. Okay, so we do the algebraic manipulation. Okay, we cancel the terms. Okay, we get yp equals half times x squared times exponent x ln x minus 3 over 4 times x squared exponent x. Okay, finally, the general solution is, okay, yc is c1 exponent x plus c2 times x exponent x plus yp, and our yp is half x squared exponent x ln x minus 3 over 4 times x squared exponent x. Okay, any question?
No, madam.
Okay, since you don't have any question, okay, we proceed with example 2. Okay, before that, I would like to remind again for those who just join the collaborative teaching. Okay, please make sure you have signed up for your attendance in UFuture. Okay, use variation of parameters to solve x times y double prime minus 1 plus x times y prime plus y equals x squared times exponent to x, given that x greater than 0, given that y equals c1 times x plus 1 plus c2 exponent x is the general solution for x times y double prime minus 1 plus x times y prime plus y equals 0. Okay, here we are given non-homogeneous differential equation with variable coefficient. Okay, this is not Cauchy-Euler, this is variable coefficient. Okay, and then we also given the general solution. Okay, we also given the general solution. So to answer this question, we do not need to find complementary solution since, okay, the general solution for the homogeneous part is already given to us. Okay, so here y1 is x plus 1. Okay, so this is y1. Okay, this is y2 exponent x. Okay, so we proceed with finding yp. Okay, look at the equation. This is variable coefficient. Okay, so we must divide the whole equation by x. Okay, must divide the whole equation by x. Okay, so we get y double prime minus 1 plus x over y times y prime plus y over x, and then term on the right hand side becomes x times exponent 2x. Okay, x times exponent 2x. Okay, next we write general form of yp. Okay, so yp is u1 y1 plus u2 y2. y1 is from the given complementary solution x plus 1. y2 is exponent x. Okay, then we find y1 prime. Okay, y1 prime, you differentiate x plus 1, you get 1. y2 prime, you differentiate exponent x, you get exponent x. Okay, then we set up system of equation. Okay, or you can write in metric forms. X plus 1, 1. exponent x for the second column. Okay, so you have u1 prime, u2 prime. And then term on the right hand side, 0, x exponent 2x. Okay, make sure, okay, this term, okay, you have divided by the coefficient of y double prime. Okay, otherwise you will get the wrong answer. Okay, next we find the Wronskian. Okay, Wronskian, you just take the coefficient matrix, okay, the 2 by 2 matrix. Okay, find the determinant. So here we get x plus 1 times exponent x minus exponent x times 1. Okay, so you get here x exponent x plus exponent x minus exponent x. Then we get x times exponent x. Okay, next, W1. W1, you replace the first column. Okay, now we replace the first column with 0 and x exponent to x. We maintain the second column. Okay, now we multiply 0 times exponent x, which is 0. Okay, minus x exponent x times x exponent to x. So we have here negative x exponent 3x. Okay, for W2, we maintain the first column. Okay, we replace the second column with term on the right hand side of the equation. Okay, then we multiply x plus 1 times x times exponent to x. Okay, minus 0 times 1. Here we get 0. Okay, so here we have x times x plus 1 times exponent to x. Okay, now we find u1 prime. Okay, u1 prime, w1 divided by w. Okay, w1 is negative x times exponent 3x. W is x exponent x. Okay, so x can be cancelled. Exponent 3x divided by exponent x, we get exponent 2x. Okay, and we have negative sign in the front. And for u2 prime, okay, w2 divided by w. Okay, so we have x plus 1 times exponent x. Okay, next we find u1. Okay, we integrate exponent to x. Okay, here, very simple integration. Okay, we get half exponent negative 2x. Okay, and then we have the negative sign in the front. Okay, u2, we integrate x plus 1 exponent x. This is u2 prime. Okay, here we use integration by parts. Okay, u is x plus 1, so du equals dx. dv is exponent x. Okay, v, we integrate exponent x dx, so we get exponent x. Okay, substitute into the formula. Okay, we have x plus 1 times exponent x minus integration of exponent x. Okay, we integrate exponent x, we get exponent x. So now we get x plus 1 times exponent x minus exponent x. Okay, so here we have x exponent x plus exponent x minus exponent x. Okay, so we get x times exponent x. Okay, next we find YP. Okay, this is Y1, U1. Okay, this is Y2, U2. Okay, so here we have negative half times x times exponent x. Okay, minus negative half times exponent x plus x times exponent 2x. Okay, so these two terms, okay, can be simplified. So we have positive half times exponent 2x minus half exponent 2x. Okay, so the general solution, okay, is C1 times x plus 1 plus C2 times exponent x plus half times x exponent 2x minus half times exponent 2x. Okay, any question?
No, madam.
Okay. Okay, we proceed with example 3. Given the differential equation x squared times y double prime minus x times y prime plus y equals 0, x greater than 0, with its corresponding solutions of y1 equals x and y2 equals x ln x, solve x squared times y double prime minus x y prime plus y equals x times 1 plus 3 over ln x. Okay, in this example, you are given a homogeneous Cauchy-Euler. Okay, this is homogeneous Cauchy-Euler. Constant variable coefficient. Okay, this is Cauchy-Euler. And then you are given y1 and y2. Okay, so you are given y1 and y2. So here, yc, okay, from C1 y1 plus C2 y2, you just substitute y1 with the given y1 and y2 with the given y2. Okay, so C1 x plus C2 x ln x. Okay, so this is yc from the given y1 and y2 in the questions. Okay. Okay, then we find yp since this is Cauchy-Euler, the coefficient of y double prime is x squared. Okay, to do variation of parameter, the coefficient of y double prime must be positive 1, So we need to divide the whole equation by x squared. Okay, so here we get y double prime minus 1 over x times y prime plus y over x squared equals 1 over x times 1 plus 3 over ln x. Okay, so make sure you divide by the coefficient on the right hand side. Okay, next we set up yp. Yp is u1 times x plus u2 times x ln x. Okay, so here y1 is x, y2 is x ln x. So y1 prime, you differentiate x, you get 1. Okay, y2 prime, you differentiate x ln x. Okay, you use product rule. Okay, so x 1 over x plus ln x. Okay, so we get here 1 plus ln x for u2 prime. Okay, then you set up system of equation, or you can write in matrix form. Okay, so x1 x ln x, this is 1 plus ln x. Okay, u1 prime, u2 prime, okay, equals 0, 1 over x plus 3 over x ln x. Okay. Okay, then we find Wronskian W. Okay, you just take this matrix, 2 by 2 matrix or coefficient matrix. Okay, you find the determinant. Okay, here we multiply x by 1 plus ln x, and then we minus x ln x times 1. Okay, so here we get x plus x ln x minus x ln x. Okay, we get x. And for W1, okay, we substitute or we replace the first column with this term, okay, term on the right hand side of the equation. And then we maintain the second column, okay. Here we get 0 times 1 ln x is 0. And then minus this term, x ln x times 1 over x plus 3 over x ln x. Okay, so here we get 0. This one negative 1 over x times ln x, we get negative x, negative ln x. And then this one 3 over x ln x times x ln x, okay, we get negative 3. Okay, so negative ln x, negative 3. Then we find W2. Okay, now we replace the second column of the matrix with the term on the right hand side of the equation. Okay, and then we multiply x times 1 over x plus 3 over x ln x, okay, minus 0 times 1, okay, 0. So we get x times 1 over x is 1. Okay, x times 3 over x ln x is 3 over ln x. Okay, next we find u1 prime. Okay, so this is W1. Okay, divide by W. Okay, so we get negative ln x over x minus 3 over x. Okay, for u2 prime, W2 divide by W. Okay, so 1 over x plus 3 over x ln x. Okay, next, we find u1. Okay, we integrate u1 prime. Okay, we integrate negative ln x over x minus 3 over x. This one can be integrated separately. Okay, first we integrate negative ln x over x. Okay, so here we use u substitution. U is ln x, du is 1 over x. Okay, so we get integration u du. Okay, so we integrate u, we get u squared over 2. Okay, and then u is ln x. So here we get this one should be negative, right? Okay, u squared over 2. Okay, we get negative half times ln x squared. And then we integrate 3 over x. Okay, we get 3 ln x. Okay, so u1 is negative half ln x squared minus 3 ln x. Okay, next we find u2. Okay, we integrate 1 over x plus 3 over x ln x. Okay, so again, we separate these two terms and we integrate one by one. Okay, we integrate 1 over x, we get ln x. Okay, and then we integrate 3 over x ln x. Okay, here we will use u substitution. In this case, u is ln x. So du is 1 over x dx. Okay, so now the integral becomes 1 over u du. Okay, so we integrate 1 over u, we get ln u. Okay, now substitute u with ln x. So u2 becomes ln x plus 3 ln of ln x. Okay, so the particular solution, okay, this is u1, y1. This is u2, y2. Okay. Okay, so here we have negative half ln x squared. Sorry, negative half. Okay, so we have negative half x ln x squared minus 3x ln x. Okay, this one we get x ln x squared. Okay, This one is 3x ln x ln of ln x. Okay. Okay, this one plus, Okay, so this term and this term, okay, you get positive half x ln x squared, okay. Then you have negative 3x ln x plus 3x ln x times ln of ln x, okay. So the general solution is, okay, C1x plus C2x ln x. Okay, I think I missed this term. Okay, so here 3x ln x. Okay. Okay, so the final answer, this is YC. Okay, this is YP. Okay, any question?
Oh. No, madam.
Okay, we proceed with the final example, example 4. Okay, this is from example 4.25 in your book or in your manual. Okay, from example 4.25. Okay, on page 132. Consider the homogeneous equation x squared times y double prime minus 4x times y prime plus 6y equals 0. Okay, so this is Cauchy-Euler, homogeneous Cauchy-Euler. If one solution is y1 equals x squared, find the second solution by reduction of order. Hence, solve x squared y double prime minus 4xy prime plus 6y equals x squared, x greater than 0 using variation of parameters. Okay. If you notice, okay, from the previous example, okay, I have given you or I have shown you three types of YC. Okay, in example 1, there is no YC given. Okay, you were only given the differential equation, so you need to find YC. Okay, for the second example, okay, you are given the complementary solution, the general solution of the homogeneous. So meaning that the complementary solution is already given. In example 3, okay, you were given y1 and y2. So you just combine y1 and y2, okay, c1 y1 plus c2 y2 for the complementary solution. In this example, you are only given y1. So you need to find y2. Okay, by doing so, you use reduction of order. Okay, then you solve the non-homogeneous Cauchy-Euler. Okay, to do reduction of order, okay, make sure the coefficient of y double prime is positive 1. Okay, so we need to divide the whole equation by x squared. Okay, here we get y double prime minus 4 over x times y prime plus 6 over x squared times y equals 0. Okay, so function p is negative 4 over x. Okay, to find y2, okay, we use this formula. Okay, so we integrate negative p over x. Okay, in our formula, we have exponent of negative of integration function p. So here, negative and negative positive. So we integrate 4 over x dx. We get 4 ln x. Then we have exponent. Okay, you just take exponent. So you get x to the power 4. Okay, and divide by the term at the bottom, x squared over x squared squared. So we get x to the power 4. Okay, so this term, we get x to the power 4 over x to the power 4 dx. Okay, so this one, we integrate dx, which is x. Okay, we integrate dx, which is x. So we get y2 is x cubed. Okay, so our YC, C1 x squared plus C2 x cubed. Okay, so this is Y1. Okay, this is Y2. Okay. So next, to solve the non-homogeneous Cauchy-Euler. Okay, since the original equation is x squared times y double prime minus 4x times y prime plus 6y equal x squared. Okay, so we divide the whole equation by x squared. Okay, so that the coefficient of y double prime must be positive 1. Okay, look at term on the right hand side. X squared over x squared, we get 1. Okay, make sure term on the right hand side you have divide by coefficient of y double prime. Okay, if coefficient of y double prime positive 1, it doesn't matter. Okay, if not positive 1, other than that, okay, it will be a problem if you do not divide by the coefficient. Okay, so yp is u1 y1 plus u2 y2. Okay, u1 is to be determined. Okay, y1 is x squared. Okay, u plus u2, y2 is x cubed. Okay, this is the general form of yp. Okay, so we find y1 prime, we differentiate to x squared, we get 2x. Okay, y2 prime, we differentiate x cubed, we get 3x squared. And then we set up system of equation. Okay, so here we get x squared 2x, x cubed, 3x squared times u1 prime, u2 prime equals 0 and 1. Okay, 0 and 1. Okay, then we find Wronskian. Okay, Wronskian, x squared, just take this coefficient matrix, okay, and then take the determinant, find the determinant. X squared times 3x squared, we get 3x to the power 4 minus x cubed times 2x, which is 2x to the power 4. So we get positive x to the power 4. Okay, and then we find W1. Replace the first column with term on the right hand side of the matrix. Okay, 0, 1, and maintain the second column. Okay, so here we get 0 times 3x squared is 0 minus x cubed times 1. So we get negative x cubed. Okay, then we find W2. We maintain first column. Okay, we substitute the second column with term on the right hand side of the matrix. Okay, so here x squared times 1, x squared minus 0 times 2x is 0, so we get x squared. Okay, then we find u1 prime, okay, w1 negative x cubed divided by w is x to the power 4, so we get negative 1 over x. Okay, u2 prime, w2 divided by w, okay, so we get 1 over x squared, or x equals x to the power negative 2. Okay, then we find u1. u1, we integrate u1 prime. Okay, we integrate negative 1 over x dx. Okay, we get negative ln x. Okay, this is simple integration. Okay, for u2, we integrate x to the power negative 2 with respect to x. Okay, we get negative 1 over x. So again, another simple integration. Okay, so yp, okay, yp, u1 y1 plus u2 y2. Okay, so here I get negative x squared ln x minus x cubed over x. Okay, and then this is the final yp, negative x squared ln x minus x squared. So the general solution is, okay, c1 times x squared plus c2 times x cubed minus x squared ln x minus x squared. Okay, any question?
No, madam.
Okay. Okay, so I have given you 4 examples. So again, okay, I will conclude what I have taught you today. Okay, so for the non-homogeneous, okay, whether this is constant coefficient or you have Cauchy-Euler or other variable coefficients, okay. So the first step, what you need to do, find YC, okay, find YC. Okay, YC from 4 examples, okay. So first, YC is not given. Okay, you need to find YC. Okay, then YC is given. Okay, given. So you do not have to find YC anymore. Okay, just use the given YC. Okay, and then for the third example, we have, you are given Y1 and Y2. Just plug in, okay? Just combine. So YC, C1, Y1 plus C2, Y2. Again, you do not have to find YC anymore. Just use the given Y1 and Y2. Okay. Then example 4, okay, you are given Y1. Okay, so need to find Y2 using reduction of order. Okay, so this is the first step, find YC. Okay, this is for the non-homogeneous case. It doesn't matter whether it is constant coefficient or variable coefficient. Okay, then find YP. Okay, find YP. Okay, write the general form of YP. So YP is U1 Y1 plus U2 Y2. Y1 and Y2 from the complementary solution. Okay, then you set up system of equation. Okay, set up system of equation. Okay, I prefer in matrix form. Okay. Okay, before that, the most important thing, okay, you need to make sure y double prime, the coefficient must be, okay, coefficient is negative, positive 1. Okay, the coefficient must be positive 1. Otherwise, you will get the wrong answer here. Okay. Okay, then you find W, Wronskian, W1, okay, W2 from this matrix. Okay, from this matrix W, and then we substitute or we replace the first column of this matrix with this matrix. Okay, we get W1, and then we replace the second column of this matrix, maintain the first column. Okay, we replace the second column of this matrix by these elements or this matrix, we get W2. Okay, and then we find U1 prime. Okay, U1 prime, W1, W2, or divide by W, U2 prime, W2 divide by W. Okay, then we find W, we integrate U1 prime. Okay, U2, we integrate U2 prime. Okay, and then we combine the answer, we get YP. Okay, you just follow the method. I think it is should not be a big problem lah. Okay, the most important thing this part, you must make sure that the coefficient of y double prime must be positive 1. Okay, this is exercise. Okay, you can do after this. Okay, given y1 equals x and y2 equals x times exponent x are the solutions to the differential equation. Okay, this is variable coefficient, but this is not Cauchy-Euler. Okay, solve the differential equation, the homogeneous and the non-homogeneous differential equation by using variation of parameter. Okay, this is like example 3. You are given y1 and y2 for the homogeneous differential equation. Okay, so here we can get yc. Okay, and then you find yp using variation of parameter. Then you find the general solution. Okay. Can I leave this one as a homework?
Yes.
Okay. Okay, last but not least, I would like to thank you for your time, for your participation in this class. Hope the lecture given is beneficial for you. Okay, thank you very much.
Thank you, madam.
Madam.
Thank you, madam.
Thank you.
Thank you, madam.